Hello, CP Finite, and welcome to 3.1 Applications Practice 1. I am going to show you a few of these examples because they can be tricky at first, but basically Practice 1, Practice 2, and Practice 3 all follow these same ideas. I believe the best way really to do these problems is to practice them, and yes, so hopefully going through these one sets of problems, you'll get confident into doing the rest. So Nuts has 60 pounds of almonds and 90 pounds of peanuts available. These are to be mixed into a 1 pound package as follows. A low-grade mixture that contains a 1/4 pound of almonds and a 3/4 pounds of peanuts, and a high-grade mixture that contains 0.5 pounds of almonds and 0.5 pounds of peanuts. Okay, and I begin scaffolding these for you and tell you, let X be the number of packages of the low grade and let Y be of the high grade. Similar to the past, when you know your variables, that is what you want to kind of have in your columns. So if we approach it similarly, we're going to have kind of creating a chart. Let X be the low grade. So low is our X, and we let Y be our high grade. That's our Y. Again, those come from the actual question. Our last little bit's going to be what we call constraints. Before it was total, now it's going to be constraints. We'll talk about those in a minute. Okay? So low grade and high grade, and then you want to kind of set it up as to, well, what is in each of the packages? Well, we have almonds and we have peanuts. Okay, and just kind of looking back through the problem, we know that we have 0.25 pounds of almonds and 0.75 pounds of peanuts in the low grade. In the low grade, we have 0.25 X, so to speak, and 0.75 peanuts, also X. High grade, similarly, 0.5 of each. And then within the constraints, information will be given to you, and that comes from the very first piece. So we only have 60 pounds of almonds. Okay, that's all Nuts has, is 60 pounds of almonds. Not more, not less. The truck that's all it's delivering. Okay? So within his mixtures, that's all he can use. Okay, he can't go over it. He could use all 60 pounds, but within the almond column, or row, sorry, we know that what he used has to be less than or equal to the 60 pounds. Okay, similarly with the peanuts, he only has 90 pounds of those, so he can only use up to the 90 pounds, okay? Now in the past, I did say it's going to be confusing when to use less than or equal to, and I will tell you pretty much all the time for our problems, I will be very specific as to when to use those, okay? So the actual systems we're going to look at here, the actual equations, are 0.25x plus 0.5 y. I'm very sorry. These should both be y's. Come on, Dvorsky. Y and y. I apologize. Okay. Y and y. Less than or equal to the 60. 0.75x plus 0.5 y. Less than or equal to 90. And also the last little bit of word problems. Okay, the other way of thinking is we can't use negative amounts of peanuts, so x must also be greater than or equal to 0, and y must be greater than or equal to 0. These should always be included, always, for word problems. Okay, we can't use negative amounts of peanuts and such. Now, graphing these, I again encourage the table method to graph, okay? These are the equations. I I will encourage you to actually look at the answers online to see the actual graphs. But again, I just at least want to get you started looking at some of these equations, okay? Mike's famous toy truck manufactures two kinds of U-trucks. What? Dvorsky? Typo. Sorry. Toy trucks. His famous company manufactures toy trucks. A dumpster and a tanker. How thrilling of a kid must it be to get a dumpster as a toy? But anyway, these problems came from the book. I do make them a little more interesting in the future. In the manufacturing process, each dumpster requires 3 hours of grinding and 4 hours of finishing. Each tanker, 2 hours and 3 of finishing. And there are 2 grinders available and 3 finishers. Okay, we'll talk about all that. Anyway, X is... well, what do I make my variables, Mr. D? Dumpsters. Dumpsters. I'll put dumps with... I'll just put that. You can get enjoyment out of it, sure. And Y to denote the number of tankers. Tank. If your parents are seeing you do these problems, they're like, what are they talking about dumps and tanks for? And again, we're going to have our constraints at the very old end. Okay. And just looking back. So you're like, okay, I got those down. What is Dvorsky saying here to move on with? Well, we have grinding and finishing to be done within each. So those are going to kind of be within our rows. Grinding and finishing. And we have a nice little chart, so to speak, to set up. Okay? Now, we fill it out similarly. So, grinding dump trucks requires 3 hours and 4 hours of finishing. And then tankers require 2 hours of grinding and 3 hours of finishing. Now, the last bit, it's a little tricky here, okay? Think of it as an employer. The company has 3 finishers and 2 grinders. I don't know why I mixed up the fonts here, but 2 grinders, 3 finishers, similar idea, okay? Each of whom are able to work 40 hours per week. What is that saying? Okay? Well, if you and a friend work at a pizza factory, a pizza store, and let's say both of you can work 10 hours, that means together you would be giving the company 20 hours of work. So, 2 grinders at 40 hours each means that my grinding time, I have 80 hours to work with. Okay? Similarly, each finisher, 3 finishers at 40 hours means I have 120 hours. Okay, that's the little tricky piece for these ones, is the constraints for those. Okay, so thinking ahead, the actual equations, 3x plus 2y less than or equal to 80, and 4x plus 3y less than or equal to 120. Also, I can't have negative dump trucks produced or negative tankers, so they must be greater than 0 and 0. Okay, again, those are the equations. Table method, again, is how I'd recommend graphing these. The answers are online as well. These are very similar again, so more financial advisory things here. Good old retired couple that have $25,000 to invest. As their advisor, you recommend they place the following, okay? Again, it's going to tell us X and Y. Let's have X be Treasury bills for X, and we will have Y be corporate bonds. Okay, now our first equation, typically, and it doesn't have to be your first, is going to be the total money they have to invest. Okay, so there's 2 places they're putting it, X plus Y, and they only have $2,500 to invest, $25,000. So they can't spend any more than that. They could maybe spend less. Okay, maybe they don't want to invest all of it, but that's our first. Now, our other equations, typically in the past, we use something with the 6% and the 9%, but it's going to be a little different here, okay? They don't tell us how much money they actually want to make, but what I do recommend them as their advisor, they should place at least 15,000 in treasury bills. At least 15,000 in treasury. Okay, so what that would look like, okay, that equation says, well, treasury bills are X, at least means it better be greater than or equal to, and 15,000, okay? Referring, whoops, whoop, 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 whoop. Okay, referring to the type of line that X is, when you graph, that's going to be a vertical line, okay? This equation, it is an equation, it's just a vertical line. Now, looking at Y, at most 10,000 in corporate bonds. So at most 10,000 in corporate bonds means that Y, if you want to keep it in the same column, you can. It needs to be less than or equal to 10,000 because that's at most. And referring back to that type of line, that's going to be horizontal. Okay. So to be clear, we have this equation, equation 1. We have equation 2. We have equation 3, and thinking what else doesn't it make sense to invest? Additional constraint we have is that, well, X is already greater than or equal to the 1500, but Y must also be greater than or equal to 0. So if you want to combine these two statements, okay, it means 0 is less than or equal to Y, less than or equal to 10,000. Okay, you can certainly do that. But keep in mind, we just can't have negative investments. Okay, so 3 or 4 equations, really, if you're getting these ones down, that's all I'd really look for. Okay, graphing the system in its corner points, and from there, again, looking at the answer key, perhaps you can interpret the meaning, okay? Preparing feed for livestock, and again, just for right now, kind of look at what you are trying to solve, the possible amounts of each grain. I don't tell you what to be X and Y here, but you're looking at the possible amounts of each grain. And, well, I have 2 types, first grain and second. Okay, so those are our variables. X is first, and Y is second. That's sloppy, but anyway, you should get the idea, okay? And again, we are going to be constrained by something. Okay, and first grain contains, so we're looking at in our rows, we have protein and iron. Protein and iron. Okay, protein in the first grain, 1 gram and 5 of iron. And protein in the second grain, 2. And iron, we have 1 gram. Okay, now our constraints are listed here. Each animal must receive at least 5 grams. Well, that means we better have more than 5 grams of protein amongst them and more than 16. Okay, so the system is simply going to be bada bing, bada boom. 1x plus 2y greater than or equal to 5. And 5x plus 1y is greater than or equal to 16. And that should give you those. Now, what else should you consider? Well, we can't have negatives involved, so x should also be greater than or equal to 0, which is also already covered, and y should be greater than or equal to 0. Okay? Now, one thing I also skipped over is labeling the corner points, and if you look at the answers, you will see I just kind of mark off where everything meets, but I can look into that more further in class. Don't want to keep you too long. Those are the basic equations that should guide you through the rest. So kudos to you for watching, and have an awesome day.